Hello, friend. Welcome to Science for Sleep. Tonight, we are drifting into the quiet world of owls. There are some animals that seem to belong to daylight. You can imagine them moving through open fields, bright skies, and warm afternoons. But owls feel different. They seem tied to another part of the world. A dimmer part, a slower part. A part shaped by moonlight, shadow, still branches, and the soft sounds that rise after most of the day has gone still. It is probably not an accident that people who stay awake late are so often called night owls. We do not call them night sparrows or night robins. We reach for the owl because the owl feels like the bird of wakefulness after dark. It is the bird we imagine listening while others sleep, alert when the world is quieter, moving naturally through the hours that feel unusual to most people. Long before that phrase became part of everyday language, owls had already become linked in the human mind with late hours, dim light, and the strange calm of being awake while most others are resting. Few birds are so deeply linked with night in the human mind. Even people who know very little about birds often recognize the feeling of an owl. The upright shape, the round face, the sudden call from somewhere unseen, the sense that something is awake while everything else is resting. And the more closely we look, the more remarkable that quiet presence becomes. Some owls can catch prey in near darkness using sound so precisely that they do not need a clear view of what they are hunting. Some can fly so quietly that the air around them barely seems to notice they have passed through it. Owls cannot move their eyes the way people can, so instead they rely on extraordinary neck motion to shift their view. And in some species, the ears are placed unevenly on the head, allowing the bird to judge where a sound is coming from with astonishing accuracy. So what can feel mysterious at first is also deeply physical. The owl does not belong to the night by accident. Its body has been shaped for that world in careful and remarkable ways. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. When most people picture an owl, they imagine stillness first. A bird resting on a branch without moving. A pale face turned into darkness. A shape that seems to be listening rather than simply waiting. That feeling is part of what has drawn humans to owls for such a long time. They do not rush through the world in the way many birds do. They seem to pause inside it. And that pause matters. An owl often hunts at times when light is weak and visual detail begins to fade. As evening deepens, the world becomes less clear to human eyes. Edges soften. Color drains away. Small movements in grass or leaves become harder to follow. But for an owl, this is not the end of useful information. It is the beginning of a different kind of awareness. The large eyes of an owl help gather light, but sight is only part of the story. Many owls also depend on a face shape to collect sound and direct it inward. The round facial disc, which gives so many owls their striking expression, helps channel tiny noises toward the ears. A faint rustle under leaves, a brief movement beneath snow, a small body shifting through grass. These sounds can become enough. That is part of what makes the owl feel so perfectly matched to darkness. Night is not empty to an owl. It is full of detail. And then, there is the silence of its flight, which may be one of the most extraordinary things about it. Many birds announce themselves when they move. Wings beat, air pushes back. Feathers cut through space with a soft rush, but owl feathers are shaped in ways that reduce noise, helping the bird travel with a hush that feels almost unreal. To the creatures below, there may be little warning at all. So the owl becomes more than just a bird active at night. It becomes a bird built for a world where hearing matters, where quiet matters, and where the difference between stillness and movement can decide everything. That may be one reason people have long seen owls as symbols of the night itself. Not only because they appear in darkness, but because they seem to understand it. They move through it with such ease that they almost feel like part of it, as if branch, air, feather, and shadow have briefly taken living form. And yet the owl is not a symbol first. It is a real animal, a bird with bones, feathers, muscles, senses, habits, limits, and needs. The quiet mystery begins there, in the body itself, and in the long shaping force of evolution. Because once we begin to look closely, the next question rises very naturally. What exactly makes an owl an owl? That question begins with something simple. An owl may feel familiar at once, but when you try to describe exactly what makes it different from other birds, the answer becomes more interesting. An owl is not just any bird that happens to come out at night. It belongs to a distinct group of birds shaped around a particular way of sensing, moving, resting, and hunting. Across the world, owls vary greatly in size, color, habitat, and behavior. Yet certain features appear again and again, tying them together into one recognizable family of life. Scientists divide living owls into two main groups. One group includes the true owls, which make up most owl species on Earth. The other includes the barn owls and their close relatives. At a glance, many people can feel the difference between them, even if they do not know the names. Barn owls often have a more heart-shaped face and a longer, paler look. True owls tend to have rounder facial discs and a broader range of body shapes. Both groups are unmistakably owls, but they show that even within this quiet branch of bird life, there is variety. That variety matters because the word owl can sound as though it describes one single form, one single voice, and one single kind of bird. But owls are not one repeating design. Some are small enough to fit easily in a human hand. Others are large, heavy birds, with wings broad enough to fill a doorway with shadow. Some live in cold northern open land, where snow stretches in every direction. Others live in forests so dense that daylight reaches the ground only in broken pieces. Some rest in barns, some in cactus holes, some in cliffs, and some in tree cavities worn open by age and weather. Even so, there are features that pull them together. One of the clearest is the face. Many owls have a facial disc, a rounded arrangement of feathers that helps collect sound. That alone makes the owl face look different from the face of a hawk, a pigeon, or a duck. The eyes also face forward, which gives many owls a direct, focused appearance. This forward-facing arrangement helps with judging distance, especially when striking at prey. It also helps explain why people often feel that an owl seems to be looking at them in a more concentrated way than most birds do. Then, there are the feet. Owls have strong toes and curved talons built for gripping. These are not the feet of seed eaters or wading birds. They are the feet of predators. The beak tells the same story. It is hooked, sharp, and made for tearing food into pieces when needed. Even in stillness, the owl body shows what kind of life it is built to live. Its feathers tell another part of the story. Many owls have plumage that looks soft, thick, and quiet. The colors are often earth tones, grays, browns, rust, cream, black or white, arranged in patterns that help the bird disappear against bark, stone, dry grass, or snow. This is one reason an owl can sit in plain sight and remain unseen. The body is not only built to hunt, it is built to vanish. And then there are the features people often misunderstand. The most famous may be the ear tufts seen on some species. These are not ears at all. They are feather structures rising from the head. Some owls have them and some do not. Scientists think they may help with camouflage or visual signaling, but they do not hear through them. The real ears are openings on the sides of the head, often hidden by feathers. In fact, many things people assume are true of all owls turn out to describe only some of them. Not all owls hoot. Not all owls are active only at night. Not all owls live in forests. Not all owls have ear tufts. Not all owls hunt mammals. The more closely you look, the more the idea of the owl starts to widen. Still, the shared pattern remains clear. Owls are birds shaped by precision. Their senses, faces, feet, plumage, and posture all lean in the same direction. Quiet awareness, controlled movement, focused attention. They are not built for constant speed or long soaring display. They are built for timing. That is why even a resting owl can feel so complete in its shape, as though every part has been narrowed toward one purpose. It does not look unfinished. It does not look improvised. It looks settled into its role. And once that role becomes clearer, another question begins to rise just as gently. If owls share this strange and recognizable design, where in the world has that design taken root? And how many different landscapes have owls quietly entered? The answer is almost everywhere. Owls are among the most widely spread birds on Earth. They live on every continent except Antarctica, and they appear in a surprising range of places. It is easy to picture an owl in a dark forest, hidden among trunks and branches, but the owl world is much larger than that. There are owls of open grassland, owls of desert edges, owls of wetlands, owls of mountain slopes, owls of Arctic ground, and owls that live not far from roads, barns, and quiet neighborhoods. That widespread tells us something important. The owl is not tied to only one kind of place. It is not a bird of one forest, one climate, or one kind of darkness. Instead, it is a body plan that has been shaped again and again to meet different landscapes, different prey, and different patterns of light and sound. Some owls live where winters are long and severe. The snowy owl, for example, is built for open northern ground where trees may be absent and the horizon stretches wide beneath a pale sky. It does not rely on dense woodland cover the way many people imagine owls do. It lives instead in tundra, where it hunts in broad spaces and must watch great distances. In that setting, the owl form is still present, but expressed differently. The body is heavy, the plumage thick, and the pale coloring fits the brightness of snow and open land. Other owls live in dense forest where trunks break up the light, and the understory holds layers of shade even during the day. In those habitats, camouflage becomes especially important. A barred owl or tawny owl may rest against bark so completely that the bird seems to dissolve into the tree itself. Here, the forest does not simply shelter the owl. It shapes how the owl sees, hears, flies, and hides. Then there are owls of open country. Barn owls are among the best examples. They often hunt over fields, meadows, marsh edges, and farmland, where low flight and careful listening can reveal rodents moving below. Their long wings and pale bodies suit that kind of hunting. They may nest in barns, church towers, old buildings, hollow trees, or nest boxes provided by people. In this way, some owls have entered human-shaped environments without losing their place as wild predators. Burrowing owls show something even more unexpected. These small owls live on the ground more than many people realize an owl can. They often nest in burrows, sometimes in holes first dug by mammals such as prairie dogs or ground squirrels. Their bodies are still unmistakably owl-like, but their daily life looks very different from that of a forest owl sitting high on a branch. They remind us that the owl form can bend into ways of living that many people never picture at first. In warmer regions, some owls hunt insects, lizards, or small birds in landscapes that feel dry, bright, and open. In tropical forests, other species move through dense green habitats, where sound behaves differently and prey may be hidden in rich layers of leaves and bark. In mountain regions, owls may live where air grows thin and weather shifts quickly. On islands, isolated owl populations may take on their own habits and forms over long periods of time. This is one of the quiet wonders of owls. They are deeply recognizable, yet never all the same. Even within one broad area, multiple owl species may live side by dividing the world in subtle ways. One may hunt mostly insects at dusk. Another may prefer mice after full darkness settles in. One may roost in conifers. Another may favor hollow trunks. One may stay low over fields. Another may remain near forest edge. This reduces direct competition and allows different owl species to share the same larger region without living the same life. Their global spread also helps explain why humans know them so well. Owls have lived near villages, farms, forests, and fields for a very long time. People across many cultures have heard them, seen them in low light, found them in rafters or ruins, or watched them lift out of trees at dusk. The details differ from place to place, but the encounter repeats. A quiet bird, a turning face, a call in darkness, a form that seems to belong to the hour when most of the world is slowing down. But to live in so many places, an animal must be more than mysterious. It must be adaptable. It must be physically suited to those conditions. And that means the next step is to look more closely at the owl body itself. Because once you realize how many landscapes owls have entered, a deeper question begins to take shape. What kind of body could be so flexible and yet remain so clearly, unmistakably owl? That answer begins with the body itself. An owl can live in many different places, but wherever it appears, it brings a familiar shape with it. Even when the colors change, even when the habitat changes, Even when one owl spends its life in forest and another in open land, the body still carries the same deeper pattern. It is a pattern built not for speed in the bright open air, but for control, balance, and exact timing. At first glance, an owl can seem almost simple in shape. The body is upright. The head looks large. The wings fold close when the bird is resting. The feathers often make the whole bird appear rounded and soft, as though the body has been wrapped in quiet. But that softness hides a highly specialized structure. Nearly every visible part of an owl reflects the demands of hunting, listening, perching, and moving in low light. The head is one of the most striking features. In many birds, the head looks small compared with the body. In an owl, it often looks unusually large. Part of this comes from the eyes, which take up a great deal of space in the skull. Part of it comes from the hearing system and the facial disc, which together shape the front of the head into something broad and attention-catching. That large head is not just for appearance. It holds some of the most important sensory tools the owl has. Beneath the feathers, the skeleton is light in the way bird skeletons usually are, but it is arranged to support a very different style of movement from that of fast, narrow-winged birds such as falcons. Many owls have broad wings and a sturdy body center, which helps them make controlled movements through cluttered environments or over uneven ground. They do not need to dive at extreme speed from high above. They need to lift, turn, slow, descend, and strike with precision. That sense of control also appears in the feet. Owl feet are powerful, and the toes are equipped with sharp curved talons for gripping prey. In some species, one of the outer toes can shift position, allowing a more flexible grip. This can help the owl hold struggling prey securely. A small animal may twist, kick, or try to escape in the brief moment after capture, and the owl's feet are built for exactly that problem. The grip must be fast, firm, and steady. The legs can be surprising too. In many perched owls, the body looks short and compact, so people may imagine the legs are short as well. But some owls have longer legs than they appear to at first glance, hidden beneath thick feathers. These legs help with striking downward, reaching through grass or snow, and balancing on uneven surfaces. In certain species that spend time on the ground, longer legs are especially useful. So the owl's shape, which can seem rounded and simple from a distance, often hides more structure than it first reveals. The beak is another quiet sign of the owl's life. It is hooked, like the beak of other birds of prey, and built for tearing food. But in many owls, the beak is partly hidden by the feathers of the face. This gives the owl a flatter appearance from the front, especially compared with hawks and eagles whose beaks stand out more clearly. The hidden beak adds to the strange softness of the owl face, even though the tool itself is sharp and effective. Then there are the feathers, which do more than cover the body. They help shape the owl's entire presence. Feathers insulate the bird against cold night air. They smooth the outline of the body. They soften the visible edges of the wings and head. They also contribute to camouflage, helping the owl blend into bark, stone, grass, or snow. In some species, the patterning is so effective that the bird seems to vanish the moment it becomes still. Even the resting posture of an owl tells part of the story. Many owls sit in a way that makes them seem gathered inward, balanced over the feet, with the head lifted and the body held in quiet readiness. They do not often give the impression of looseness or distraction. Even at rest, there is a sense of contained awareness, as though the whole body is waiting without tension. That may be why owls feel so complete in shape. Nothing about them looks accidental. The broad wings, the large head, the hidden legs, the gripping feet, the hooked beak, the heavy softness of the feathers, all of it leans toward the same result. A bird that can remain still for long stretches, then act with remarkable precision when the right moment comes. And perhaps nowhere is that precision more visible than in the face itself. Because the owl's face is not only memorable, it is one of the most unusual faces in the bird world, and much of its strangeness begins with the eyes. That strangeness begins with the feeling of being watched. An owl's face is one of the few bird faces that can seem almost uncannily direct to human eyes. Much of that comes from the eyes themselves. They face forward, they appear very large, and they sit within the face in a way that gives the owl an unusual sense of focus. Most birds have eyes placed more toward the sides of the head, which gives them a wide field of view. Owls are different. Their eyes are positioned in a way that allows both eyes to look more closely at the same space ahead. That overlap matters because it helps with depth perception. When both eyes are directed toward the same part of the world, the brain can compare the two views and judge distance more accurately. For an animal that often has to strike prey with exact timing, that is a major advantage. A hunting owl does not simply need to notice movement. It needs to know where that movement is in space and how far away it is. The eyes themselves are also unusually large for the size of the bird. In some species, they take up so much room in the skull that there is little space left for the kind of movement human eyes can make. A human eye is shaped more like a ball and can turn freely within the socket. An owl's eye is shaped more like a tube, longer than it is wide, and held much more firmly in place. This helps the owl gather light efficiently, but it also means the eyes cannot roll around the way ours can. That single fact changes a great deal. When people notice an owl turning its whole head to look in another direction, they are seeing the result of fixed eyes. The bird is not adding drama. It is solving a real anatomical problem. The eyes stay still, so the head must do the work. Large eyes also help with one of the owl's most famous strengths, seeing in low light. The bigger the eye, the more light it can gather. That matters at dusk, at night, and in dim forest interiors where visual detail is limited. Owl retinas are especially rich in rod cells, which are the light-sensitive cells that help with vision in darkness. Rods do not provide strong color detail, but they are very good at detecting low levels of light and movement. This makes them valuable in the world where many owls live and hunt. That does not mean owls possess magical vision. They do not see perfectly in absolute darkness. No eye can create an image when there is no light at all. But in faint light, the owl eye performs impressively. Moonlight, starlight, twilight, and weak reflections are often enough to give the owl useful visual information. In those conditions, what seems dim and uncertain to a human may still hold shape, distance, and movement for an owl. Because of their eye design, owls often have excellent forward vision, but they do not have the same broadside view that many other birds enjoy. A pigeon or duck can monitor a wide world around itself without turning much. An owl gives up some of that wide-angle awareness in exchange for stronger forward focus and better binocular depth judgment. That trade makes sense for a predator that often waits, listens, and then commits to a precise movement, rather than constantly scanning with the body in motion. Another quiet detail is that owl pupils can open very wide. This helps more light enter the eye in dim conditions. In bright daylight, the pupils narrow. In low light, they widen again. This change happens in many animals, of course. But in an owl, the effect can seem especially striking because the eyes already look so large and expressive. Yet for all this emphasis on night vision, not all owls live only in deep darkness. Some species hunt more often at dawn or dusk. Some are active at times when light is still present. Some live in places where snow, open sky, or pale ground reflect more light than people might expect at first. So owl vision is not simply night vision in the dramatic sense. It is better understood as low-light vision, shaped by species, habitat, and habit. Still, the feeling remains. To look into an owl's face is to feel that the bird is built around seeing, with unusual seriousness. The large eyes, the forward gaze, the stillness, all of it makes the owl seem intensely attentive, even when it is resting. That is part of why the face has stayed so deeply in human imagination. The eyes look less like quick bird eyes and more like instruments set into the front of the skull. And once those instruments are fixed in place, another question follows almost immediately. If an owl cannot move its eyes the way we can, then how does it shift its view so quickly and with such eerie ease from one part of the darkness to another? The answer lies in motion, but not the motion most people expect. When an owl changes its attention, it often does not shift the eyes inside the face the way a person would. Instead, the whole face seems to turn. The head rotates with a smooth and sometimes startling ease, as though the bird has simply poured its awareness into a new direction without disturbing the rest of the body. That movement can feel uncanny when seen in dim light, but it is not mysterious in the supernatural sense. It is a practical solution to a very real anatomical limit. Because an owl's eyes are held so firmly in place, the head must take over much of the work of looking. A human can glance sideways with barely any visible movement at all. An owl cannot do that. If it wants to inspect a sound behind it, a movement to one side, or a shift in the branches nearby, the head must turn. And it can turn much farther than ours can. Humans usually rotate the head only a modest amount before the neck begins to resist. Owls can rotate the head far more, giving them a much wider field of view without having to move the whole body from the perch. This is useful in several ways. It allows the owl to remain balanced and quiet. It helps keep the body still when stillness matters. And it lets the owl scan a large part of the world while making only a small outward change. That ability depends on the structure of the neck itself. Owls have more neck vertebrae than humans do, which gives them greater flexibility and a wider turning range. The joints between those vertebrae also allow a different kind of movement from the one our necks are built for. In an owl, the neck is not an afterthought holding up the head. It is a major part of the animal's sensory system because it helps the bird reposition its eyes and hearing structures quickly and quietly. The blood supply has to solve a problem too. When a head turns very far, blood vessels can be placed under strain. In a human, extreme neck twisting can reduce blood flow. Owls avoid this problem through specialized arrangements in the vessels of the head and neck that help protect circulation during large head rotations. In simple terms, the owl's body is built to keep blood moving, even while the head turns in ways that would trouble many other animals. So the famous owl head turn is not a trick layered on top of the body. It is part of the body's basic design. The fixed eyes made a new solution necessary, and over time the neck became that solution. It also changes the visual impression the bird gives to others. Many animals shift attention through small eye movements, quick body turns, or restless scanning. The owl often does something else. It holds the body steady, then turns the entire face. That makes the change in attention much more visible. A branch may remain perfectly still. The shoulders do not move. The wings stay folded. And then suddenly, the face is aimed elsewhere, as though awareness itself has swung through the dark. That is part of why owls seem so alert. The movement is slow enough to notice and direct enough to feel deliberate. A small sound in grass, a flicker at the forest edge, a movement beneath snow, and the whole face aligns with it. The owl appears to gather the world not in scattered glances, but in full turns of attention. It is also worth noticing that this helps the owl remain hidden. A bird that constantly shuffles its feet, bobs its body, or changes perch position would be easier to spot. By turning the head instead of the whole body, the owl can keep its outline stable. For a predator, that often depends on patience. That matters. Stillness is part of the hunt. So the neck becomes more than a connector between head and body. It becomes a quiet instrument of perception. It allows the owl to overcome the limits of its eyes, preserve its balance, hold its camouflage, and shift its awareness with remarkable control. But even that famous head turn is only part of the story, because some of the owl's most extraordinary awareness does not come through sight at all. It comes through hearing. Now the owl moves deeper into a world that many humans barely notice. If vision gives the owl a picture of the night, hearing often gives it the finer map. In darkness, shape begins to fade. Edges soften. Color becomes less useful. Small movements vanish more easily into shadow. But sound does not disappear when light grows weak. In some ways, it becomes more important. A faint rustle in dry leaves, a light movement through grass, the soft disturbance of snow above a hidden animal. These small sounds can carry information that eyes alone may not provide. For many owls, hearing is one of the most remarkable tools they possess. The owl's face is part of that system. What looks to us like a round or heart-shaped face is not only an expression. In many species, the facial disc acts like a sound collector. The feathers of the face help gather and direct sound inward toward the ear openings, which are hidden beneath the feathers on the sides of the head. This means the owl face is doing more than looking outward. It is listening outward too. That is one reason an owl can seem so intent when it sits still. The stillness is not empty. The bird may be taking in tiny differences in sound from the ground below or the branches around it. A small mammal moving through leaves may create only the faintest noise, but to an owl, that noise can be enough to reveal position, motion, and distance. In some owl species, the ears are not placed at the exact same height. One ear opening sits slightly higher than the other. This is called asymmetry, and it allows sound to arrive at the two ears in slightly different ways. A noise coming from below may reach one ear a fraction sooner or more strongly than the other. A noise from above will produce a different pattern. The owl's brain can compare these tiny differences and use them to judge where the sound came from, not only from side to side, but from up and down as well. That is a remarkable ability, because humans are usually better at judging left and right than height when using sound alone. In an owl, the system can be far more refined. The bird is not simply hearing that something moved. It is building a spatial answer from that sound. It is locating the movement in 3 dimensions. This is especially useful in dim habitats where prey may be partly hidden. A vole beneath snow, a mouse under grass, or a small animal moving under leaf litter may not offer a clear visual target, but it still produces sound. In some cases, owls can strike with extraordinary accuracy, even when the prey is difficult to see clearly, relying heavily on hearing to guide the attack. The brain must do a great deal of work to make that possible. Owl brains contain highly developed auditory pathways that process timing and intensity differences with great precision. Sound enters the ears, is compared, sorted, and translated into position very quickly. In effect, the owl is not only hearing sound, it is turning sound into location. This also helps explain why silence matters so much to owls. In a noisy environment, the smallest prey sounds would be harder to separate from everything else. Wind through leaves, water movement, human machinery, and other background noise can interfere with fine listening. But in calm nighttime air, subtle sounds travel cleanly. A quiet branch, a cold field, a still forest floor. These are not just settings that feel atmospheric to us. They are listening conditions. And that listening is not passive. An owl may tilt its head slightly, pause, or remain motionless for long stretches because it is refining a sound picture. To a person watching, it may seem as though nothing is happening. But the bird may be making very fine judgments about distance, direction, and timing. This is part of what gives owls their strange relationship to darkness. Darkness does not remove the world for them in the way it often does for us. It changes the balance of information. Sight may narrow, but sound expands. The hidden becomes partly knowable again through the ear. That may be why owl awareness feels so unusual when people witness it. A turning face in low light can already seem intense. But when that face is turning not just toward what is seen, but toward what is barely heard, the effect becomes even stranger. The owl seems to respond to things that remain invisible to us. And if an owl can hear so well, another quiet question follows close behind. How does such a bird move through the air without disturbing the very sounds it depends on? The answer begins in the feathers. By now, the owl can feel almost impossible in its design. It can see in very low light, hear with astonishing precision, and turn its head in wide, careful arcs, while keeping the body still. But all of that would be less useful if the bird announced itself every time it left the branch. A hunter that depends on surprise and on fine listening cannot afford to move through the air with too much sound. So the owl solves that problem in a way few other birds do. It flies quietly, not perfectly silently, because no wing moving through air can produce no sound at all, but quietly enough that the effect can feel unreal when an owl passes nearby. Many people who have seen an owl fly at close range remember not the force of the movement, but the lack of noise. The bird seems to drift rather than beat its way forward. It seems to pass through darkness as though darkness itself were carrying it. That impression comes from structure. Owl feathers are shaped differently from the feathers of many other birds. On the leading edge of the wing, the front edge that first meets the air, there are small comb-like fringes on many species. These fine projections help break up the air as it passes over the wing, reducing the larger turbulent sounds that might otherwise be produced. Instead of one stronger rush of disturbed air, the wing spreads that disturbance into smaller, softer patterns. The trailing edge of the feathers matters too. It is often softer and more ragged than the edge seen in birds built for speed or open-air efficiency. This softness helps reduce the sharp sound that can happen when air slips off the back of a stiff feather edge. In simple terms, the owl wing is shaped not only to lift the bird, but to soften the sound of lifting the bird. Then there is the surface of the feathers themselves. Owl feathers often have a velvety texture that helps dampen the rubbing noise of feather against air and feather against feather. This gives the plumage a softness that matters not just to touch or appearance, but to acoustics. The whole wing becomes quieter because its surfaces are less harsh in the way they meet motion. All of this means that owl flight is not only about getting from branch to branch. It is about controlling the sound made during that travel. The air still moves. The wings still push downward and outward. Lift is still created, but the noise is reduced in a way that serves the owl's larger life. That life depends on surprise. A mouse in dry grass may survive if it hears danger a moment early. A vole under leaves may freeze or dart if warned. A small bird at rest may launch upward if there is even a brief rush of air that sounds wrong. By reducing wing noise, the owl shortens the warning it gives. It brings the strike closer to the moment of awareness, and in some cases may make awareness come too late. Quiet flight also helps the owl itself. A bird that hunts by hearing cannot flood its own sensory world with the loud sound of its wings. If each wing beat produced too much noise, fine prey sounds would be harder to detect while airborne. So the silent wing is not only a weapon against prey, it is protection for the owl's own hearing. The bird moves more quietly through its environment and preserves the sensory detail it needs along the way. This is one of the clearest examples in nature of form and function leaning in the same direction. The owl's feathers do not simply happen to be soft. They are soft in ways that matter. The face collects sound. The ears compare it. The brain maps it. And the wings help prevent that map from being covered over by the noise of the bird's own movement. It also changes how owl flight looks to human eyes. Falcons can seem sharp and forceful. Pigeons can seem quick and busy. Gulls can seem broad and open. But an owl often looks muted in motion, as though the body were gliding through a thicker kind of air. Even the wing beats can seem cushioned. The movement lacks the hard visual edges that many other birds show. That is part of why the flight feels ghost-like. not because it is unreal, but because the usual signs of effort and sound have been softened. And that softness returns us to the larger pattern. Everything about the owl so far has pointed toward precision in low light. The eyes, the ears, the head turning, the face, the feathers. Nothing stands alone. Each trait supports the others. So by this point, the owl can see, hear, and move through darkness with astonishing precision. The next question is what happens at the moment all of those abilities come together in a hunt. What happens next is usually very fast. For a long time, the owl may seem almost motionless. It may sit on a branch, a fence post, a beam, or a low rise in the ground, holding its body in perfect balance. The face turns slightly, the head tilts, the eyes stay wide and steady. The ears continue gathering tiny clues from the darkness below. To anyone watching, the bird may appear calm enough to be resting. But in many cases, it is not resting at all. It is measuring. That is one of the most important things to understand about how many owls hunt. They often do not chase prey over long distances the way some other predators do. They do not usually win through speed alone. Instead, they wait, listen, watch, and then move in a short burst when the timing is right. The hunt is often less like a pursuit and more like a solution reaching its final moment. When that moment comes, the movement can be sudden but controlled. The owl leaves the perch, drops or glides toward the target, and brings the feet forward at the right instant. In many species, the feet are the first and most important tools of capture. The talons are curved and sharp, built to seize and hold. A small mammal caught in those feet may struggle violently for a brief moment, and the owl must keep its grip firm enough to prevent escape without losing balance. That grip is not only about sharp claws, it is also about force and timing. The toes close around the prey with great speed, and in some owls, the toe arrangement can shift slightly to improve control. Once the feet close, the strike is often already decided. The beak plays its part as well, though often after the main capture. If the prey is small enough, some owls swallow it whole. If it is larger, the owl may use the beak to tear it into pieces that can be managed more easily. The hooked shape of the beak makes this possible. It is not used in the same way as the talons, but it remains an important part of feeding once the prey has been secured. The whole sequence depends on coordination. Hearing may guide the owl to the general location. Vision may confirm distance, motion, or outline. The wings must carry the bird into the right position without causing too much disturbance. The legs must extend at the correct moment. The feet must close fast and hold. Even a small mistake in timing can matter, especially if the prey is quick and the opportunity is brief. That precision helps explain why owls are so often still before they move. Stillness gives the bird a better chance to judge. A moving predator creates more sound, changes its own angle, and may lose some of the sensory detail it needs. A still predator can gather information more clearly. Then, when the strike begins, it is not an uncertain guess. It is the release of many quiet seconds of listening and watching. In some situations, the strike happens downward from a perch. In others, the owl may already be flying low when it adjusts and drops. In snowy or grassy places, it may even reach into cover where the prey is not fully exposed. This is where the owl's ability to combine sound with movement becomes especially remarkable. The target may not be clearly visible in the way humans imagine a target should be. It may be partly hidden beneath thin snow, leaves, or grass. Yet the owl can still make a highly accurate attempt because it is striking not only at what it sees, but at where the sound has told it life is moving. To a human watcher, the moment can feel almost magical because so much of the preparation is invisible. You may only notice the final movement. A bird that seemed carved into the branch suddenly becomes motion. Wings open, the body drops, the feet extend. Then stillness returns, but in a new place. Yet there is nothing magical about it in the unreal sense. It is the product of anatomy, timing, practice, and evolved design. The owl has not been built to dominate the night through force alone, but through fit. Its body answers the problems of darkness with unusual care. The strike is simply where all of those answers meet. And even here, there is no single owl method, because one of the quieter truths about owls is that different species solve the problem of food in very different ways. That difference begins with a simple truth. There is no single owl hunt. The image many people carry is easy to picture. A quiet owl on a branch, a drop through darkness, a mouse in the grass below. And while that picture is real, it is only one version of owl life. Once you begin looking across many species, the hunting world of owls becomes much wider. Some hunt low over fields, some wait inside forests, some search from the ground, some take insects, some take fish, some are built for tiny prey. Others are powerful enough to seize animals far larger than people expect. So the owl is not one hunter repeated again and again. It is a family of hunters, each shaped around a particular place, a particular prey, and a particular way of using the body. Barn owls are among the clearest examples of open country hunting. They often fly low over grassland, farmland, marsh edges, or fields, holding their wings in a steady, buoyant way as they listen for rodents below. Their long wings and strong hearing make them especially suited to this style. Rather than crashing through tight branches, they often work over broad open ground where sound can rise clearly from the grass. Woodland owls often do something different. In a forest, the world is broken into trunks, branches, shadows, and uneven spaces. A bird hunting there may rely more on perches, waiting quietly before dropping toward prey below, or moving from one branch to another in short, controlled flights. In that setting, agility and exact movement through clutter matter more than long, low sweeps over open land. Then there are owls that live closer to the ground than many people imagine an owl can. Burrowing owls, for example, often spend time on the ground near the mouths of burrows. They may run, hop, or stand upright on open earth, and they frequently hunt insects as well as small vertebrates. Some are active in daylight more than the word owl might lead people to expect. This reminds us again that not all owls are deep night forest birds. Some live in bright open places under wide skies, with hunting habits shaped by that openness. Small owls often focus on small prey. Insects can make up a major part of the diet for some species, especially in warm seasons or in regions where insect life is abundant. Beetles, moths, grasshoppers, and other invertebrates may be taken regularly. A tiny owl does not need the same kind of power as a large one. It needs speed, sharp timing, and the ability to recognize and catch what is appropriate for its size. Larger owls, of course, can attempt much bigger prey. Rabbits, large rodents, birds, and other small mammals may all become part of the hunt, depending on the species and the habitat. In some cases, very large owls are capable of taking prey that seems surprisingly substantial for a bird. This changes not only the strike, but the risk, the grip required, and the way food is handled afterward. Some owls hunt near water. Fish owls and certain other species can take prey from shallow water or from the edge of streams and lakes. This introduces a very different kind of environment, one where sound behaves differently, surfaces move, and prey may be slippery or partly submerged. The owl body still appears, but the problem it is solving has changed. Time matters too. One owl may hunt mostly after full darkness settles in. Another may be more active at dusk, at dawn, or even during the day in the right season or habitat. Snowy owls, for example, often live in places where long summer days and open northern light change the usual meaning of day and night. Burrowing owls may be seen hunting when the sun is still up. So even the timing of the hunt is not fixed across all owls. The more closely you look, the clearer it becomes that hunting style depends on several things at once. Habitat matters. Body size matters. Prey type matters. Light level matters. Season matters. And the same owl may even change its emphasis as conditions change around it. That flexibility helps explain why owls have spread so widely across the planet. They are recognizable as a group, but not rigid in how they live. The owl form has been adapted many times to different hunting problems, and each species carries its own answer. Still, whatever the method, every meal leaves a trace. Once the prey is caught, swallowed, or torn apart, the owl begins another strange and useful process. Because after the hunt comes one of the oddest owl facts of all, and one of the most valuable to science. The owl leaves behind a record of its meals in a form that can actually be read. That record begins quietly, and at first it does not look like much. An owl may feed, rest, and later leave behind a small grey or brown mass beneath a perch, in a barn, under a tree, along the beam of an old building, or near a nesting place. To someone passing by, it might look like a bit of felt, or a dry clump of fur. But inside that small object is a surprising amount of information. Bones, teeth, bits of feather, and compacted fur may all be folded together in a way that tells a detailed story about what the owl has eaten. This is the owl pellet. Pellets form because of the way many owls handle food. Small prey is often swallowed whole, or in large pieces, rather than chewed in the mammal sense. Soft tissues, such as muscle and organs, can be digested. But harder materials do not break down so easily. Bones, teeth, claws, fur, feathers, and other indigestible parts are gathered together inside the digestive system and compressed into a tight mass. Later, the owl brings this mass back up and regurgitates it. That is an important detail. A pellet is not the same as ordinary waste passing through the full digestive tract. It is a separate package of material that the owl cannot digest and therefore removes by bringing it back out through the mouth. By the time the pellet appears, the soft tissues are gone, and the durable remains have been pressed into a form compact enough to expel. This process can sound strange at first, but it is a practical solution. If an owl regularly swallows prey whole, it will also regularly take in a great many materials that have food value for the prey animal, but not for the owl. Fur can insulate a mouse, but it does not nourish the owl. Bones can support a vole, but many of those hard parts remain difficult to digest. The pellet solves the problem by separating what can be used from what cannot. And this is where the pellet becomes so valuable to science. Because the hard remains often stay recognizable. Scientists, students, and naturalists can take pellets apart and identify the prey inside them. A tiny jawbone may reveal a vole. Teeth can distinguish one small mammal from another. Fragments of skull, leg bone, feather, or insect shell can all provide clues. With patience and comparison, a person can reconstruct a surprising amount from what looks, at first glance, like only a dry little bundle. That means pellets are not only leftovers. They are records. If many pellets are collected from one site over time, they can reveal what kinds of prey live in the surrounding area. They can show whether an owl is eating mostly mice, mostly voles, more birds in one season, more insects in another, or different prey entirely depending on habitat. In this way, the owl becomes an accidental sampler of its ecosystem. It gathers animals from the landscape and later leaves behind evidence of that gathering in a form that can be studied. This has made owl pellets useful in classrooms as well as in field science. Students dissecting pellets often get their first close look at the hidden lives of local small mammals. A barn may seem quiet and ordinary from the outside, yet the pellets below a roost can reveal an entire unseen community of creatures that move through the nearby grasslands, fields, and hedges by night. Pellet study can also help researchers understand habitat quality. If prey remains change over time, that may suggest changes in land use, vegetation, farming methods, climate conditions, or prey cycles. In that sense, the pellet becomes a small ecological archive. It reflects not only the owl's diet, but something about the world the owl is hunting in. The process is also a reminder of how tightly form and habit stay linked in our life. The hooked beak, the grip of the feet, the swallowing of prey, the digestive sorting, and the later regurgitation of the pellet all belong to the same larger pattern. The owl does not simply catch food and make the evidence disappear. It transforms the evidence into another form. And there is something quietly fitting about that. An owl is so often associated with hidden things, with darkness, with movements people rarely witness directly. Yet one of the clearest traces it leaves behind is something that can be picked up, opened, and read. It is as though the bird, without meaning to, writes notes about the landscape in bone and fur. Pellets reveal what owls take from the world around them. And once that question settles, another begins to rise just as gently. How do owls themselves begin their own lives within that same landscape? First as eggs, then as chicks, long before they become the silent hunters of the night. For all the control an adult owl seems to carry, its life begins in a far quieter and more fragile way. The finished owl can feel self-contained, as though it arrived in the world already shaped for darkness, already fitted with the eyes, ears, feathers, and balance it needs. But like any bird, it begins as an egg. And before that egg can hold a growing chick, there must first be a place chosen carefully enough to shelter it. Most owls do not build elaborate nests in the way many songbirds do. They are often less interested in weaving a new structure than in finding a location that already solves the problem of safety. A hollow tree can do that. So can an abandoned nest built by another bird, a ledge on a cliff, a cavity in an old building, a burrow in the ground, or even a simple scrape in a protected place. The owl's approach is often less about construction and more about selection. That selection matters deeply because the nest site shapes nearly everything that follows. Temperature, moisture, wind, exposure to rain, access to food, and the risk of predators all become part of the future of the eggs. A tree cavity may offer shelter from weather and concealment from view. A barn loft may provide dryness and protection. A burrow may buffer temperature swings and hide the eggs from open country threats. A poor nest site, by contrast, can expose eggs and chicks to cold, heat, wet conditions, or unwanted attention from predators. Different owl species solve this problem in different ways. Barn owls may settle in buildings, hollow trees, or nest boxes. Burrowing owls use underground spaces, often ones first dug by mammals. Large forest owls may use broken-top trees or old stick nests left behind by hawks, crows, or other birds. Some cliff-living owls choose rocky ledges where the eggs rest with little more than the shelter of stone around them. The variety is wide, but the principle remains the same. The owl is looking for a place that gives its young the best chance to begin. Once the nest site is chosen, the female lays eggs, often in a number that reflects both species and circumstance. In many owls, the clutch is not especially large compared with the clutch sizes of some smaller birds, yet it can vary significantly. Food supply plays a major role. In years when prey is abundant, especially in species that depend heavily on rodents, some owls may lay more eggs. In lean years, fewer eggs may be laid, or breeding may not happen at all. This is one way owl reproduction stays tied to the wider pulse of the landscape. That timing is important. If a species feeds mostly on small mammals, then breeding too early or too late may place hungry chicks into a world that cannot support them. But if egg laying is matched to prey abundance, the parents have a better chance of finding enough food when the chicks hatch and begin demanding constant care. In this way, the nest does not belong only to the owl pair. It belongs partly to the field, the forest floor, the grassland, or the tundra that will have to provide food for the family. During incubation, there is often a clear division of labor. The female may spend long periods sitting on the eggs, keeping them warm and protected, while the male hunts more often and brings food. This pattern varies across species, of course, but the general rhythm is common. One parent guards the stillness of the nest, while the other moves through the outer world, collecting what the nest will need. It is a quiet partnership shaped by energy, timing, and trust. The eggs themselves are usually pale, often white, as is common in many cavity nesting birds, where camouflage matters less than it would in an exposed open nest. Their stillness can make the nest seem uneventful from the outside. Yet inside the shell, the owl is beginning in secret. Bones form, feathers begin, eyes develop. The body that will one day move through darkness starts here in warmth, silence, and waiting. And there is something fitting in that. An animal so associated with alertness begins in stillness. A bird that later seems made for certainty begins in dependence on place, weather, food, and parental care. The nest, however simple it looks, becomes the first real answer to the question of survival. So before the owl becomes a watcher in darkness, it is first something hidden, sheltered, and growing in a borrowed hollow, a quiet loft, a burrow, or a ledge, shaped as much by the safety of the nest as by the life inside the egg. And once the eggs hatch, the owl's quiet precision is nowhere to be found at first. What follows instead is a much softer and more awkward beginning. What emerges from the egg is not the finished shape people carry in their minds. It is not the still face on the branch, not the silent hunter moving through darkness, not the calm and watchful figure that seems so complete in adulthood. The young owl begins in a much softer form. It is small, down-covered, unsteady, and deeply dependent on others. For a time, nearly everything it needs must be provided from outside itself. Newly hatched owl chicks are helpless. Their bodies are still developing, their movements are uncertain, and they depend heavily on parental care. They need warmth, food, shelter, and protection. At first, the nest is not simply a place where they happen to be. It is the entire boundary of their world. Their first covering is down, not the full set of feathers that will later support flight and shape the familiar outline of the owl. Down helps trap warmth close to the body, which is essential because young chicks cannot regulate temperature as well as adults can. The nest must stay warm enough, and the parent brooding over the chicks often remains important in the early period after hatching. The adult body becomes part of the shelter, covering the chicks from chill air and helping steady their first days. Food arrives through the parents, and in the beginning that matters constantly. A chick cannot leave, cannot hunt, and cannot choose its own timing. It waits, receives, and grows. The adults return with prey, often torn into manageable pieces for the youngest chicks. As the chicks gain strength, feeding continues, but their bodies begin to do more of the work of development. Bones lengthen, feathers begin replacing down, eyes open more fully. The soft form starts to sharpen into something more recognizably owl-like. Even within one nest, growth may not be perfectly even. In many owl broods, chicks hatch at slightly different times because eggs are often laid and incubated in sequence rather than all beginning development at exactly once. This can create a size difference within the brood. One chick may be noticeably larger and stronger than a younger sibling. In years of plentiful food, several chicks may grow well despite that age gap. In poorer conditions, the difference can matter more. Food may not be enough for every chick to thrive equally, and the nest may begin to show the pressures of the wider environment. So even here, in what seems like a private family space, the condition of the landscape still reaches in. If rodent numbers are high, the chicks may grow well. If weather turns harsh, prey drops, or hunting becomes difficult, development can become more uncertain. The young owl is never separate from the world beyond the nest. It is tied to field, forest, weather, and prey, long before it ever sees much of that world for itself. As the chicks grow, they become more active and more awkward at the same time. The body is changing quickly, but coordination comes more slowly. Wings may flap before flight is truly possible. Feet may grip clumsily. Balance may come and go. In tree nesting species, this often leads to an unusual stage known as branching. Before the young owl can truly fly, it may leave the nest area and climb, hop, or scramble among nearby branches. To a human observer, this stage can look uncertain and almost comical, because the young bird is no longer where it began, but is not yet capable of the controlled flight that defines adulthood. And yet branching is important. It is part of learning space, balance, grip, and movement outside the nest. The young owl begins to occupy the world in a larger way. Its body is not ready for full independence, but it is being introduced to height, distance, and the unstable surfaces it will later use with ease. Gradually, the full feathers come in, the outline changes, the face becomes clearer, the wings take shape. The body that once seemed like only a soft bundle of down starts to resemble the predator it will become. But that transformation is not instant. It takes time, food, safety, and many repeated chances to grow without disaster. Juvenile survival depends on many things working in the owl's favor. The nest must remain secure. Weather must not turn too harsh. Food must continue arriving often enough. The young bird must avoid falling too early into the risks of the outer world. And when independence finally begins, it must learn quickly. Hunting, roosting, moving, and responding to danger all have to become real skills, not just inherited potentials waiting in the body. So the young owl is a reminder of something easy to forget. The finished adult can seem almost inevitable, so well designed that it feels complete from the start. But nothing about it is immediate. Even one of night's most precise hunters begins as something soft, unstable, and still learning how to exist. And as young owls become more aware, one of the first things that shapes their lives is sound, not only for hunting, but for communicating. Long before an owl is clearly seen, it is often heard. That is one reason owls feel so deeply tied to the night in human experience. The darkness may hide the body, but the voice can still travel through open air, across a field, between trees, over roofs, through cold branches, or out from the edge of a forest. A person may hear an owl without ever finding it. The sound alone can fill the space enough to create the feeling of a living presence nearby. But those sounds are not random, and they are not meant for us. Owls call for real biological reasons. Sound helps them claim territory, attract mates, maintain pair bonds, and send signals to others of their own kind. In darkness or in thick cover where visibility is limited, a call can do what posture or wing display cannot. It can carry through space and announce that an owl is present, where it is, and sometimes what it wants. This matters especially in breeding season. At that time, calling often increases because the stakes are higher. A territory must be defended. A mate must be found or kept close. Nest space matters. Food matters. Distance between neighboring owls matters. The night becomes more crowded with meaning, even if it still seems quiet to human ears. One of the most familiar owl sounds to people is the hoot. But not all owls hoot. That is important to remember. Some whistle, some bark, some shriek, some hiss, some trill. Some produce sharp screeches that sound nothing like the deep, rounded calls many people expect. The owl voice is not one sound repeated across the whole group. It is a wide range of signals shaped by species, body size, habitat, and purpose. Body size plays a role because larger animals often produce lower sounds. A bigger owl may create a deeper call that seems to roll outward through the air. Smaller owls often produce higher voices, sharper notes, or quicker repeated phrases. Habitat matters too. In forests, sound moves through trunks, leaves, and branches, so certain calls may carry more effectively than others. In open country, a different shape of sound may travel farther. Over long periods of time, those conditions help shape the voices different owl species use. Some calls are simple and repeated. Others come in paired phrases, rising notes, descending notes, or patterns that are easy for another owl to recognize. To us, a call may sound lonely, eerie, or beautiful. But to another owl, it may be full of exact information. It may say, "This place is occupied." It may say, "I am here." It may say, "Answer me." It may say, "Stay away." Young owls call too, though for different reasons. Nestlings and newly fledged young may beg for food, contact the parents, or signal distress. These sounds are part of family life rather than territorial life, but they are just as important to survival. A young owl that cannot yet hunt depends on being heard by the adults that bring food and protection. This is one reason the human idea of owl calls as haunting can be misleading, even though the feeling itself is understandable. When people hear a strange voice in darkness, especially one they cannot easily place, the sound can feel ghostly or unsettling. But the call is not meant to frighten. It is part of a real communication system, shaped by selection, timing, and need. The mystery we feel often comes less from the sound itself than from our distance from its meaning. And because the sound arrives without the body, the imagination has room to work. A deep hoot from unseen branches can feel larger than the bird itself. A sudden screech in night air can feel more dramatic than the small owl making it. Sound stretches the presence of the owl beyond what the eye can confirm. It lets the bird inhabit darkness in a way few other creatures do so effectively. That may be one reason owls stay with people so strongly in memory. A shape glimpsed once may fade, but a call heard at night, when everything else is still, often settles more deeply. It marks the air. It changes the feeling of the place. It reminds the listener that the darkness is occupied. Those calls are heard because the owl is there, but very often the owl itself is not seen. That depends not only on darkness, but on plumage that helps the bird dissolve into its setting. An owl is often present long before anyone notices it. That is one of the quiet truths of owl life. The call may reveal the bird sometimes, and movement may reveal it at other times. But very often, the owl remains hidden simply because the body is so well matched to its surroundings. A person can look directly toward an owl and still fail to see it. Not because the bird is especially small, and not because it has vanished in any magical sense, but because its feathers and posture are working exactly as they should. Owl plumage is often colored in ways that match the places where the bird rests. Browns, grays, rust tones, black streaks, pale cream, white, and muted tan all appear again and again across owl species. These are not bright, clean blocks of color. They are broken colors, mottled colors, layered colors. The patterns resemble bark, dry grass, leaves, lichen, dirt, rock, or snow, depending on the species and habitat. This helps the owl blend into the visual complexity of the world around it. That blending is not simple sameness. The feathers do not need to match one exact surface perfectly. Instead, they break up the outline of the body. A perched owl is a shape that might otherwise be easy to notice. It has a head, a back, shoulders, and a clear vertical form. But mottled plumage interrupts those edges. Light patches and dark streaks make the boundary of the body harder for the eye to separate from the background. The result is that the owl begins to look less like an animal and more like part of the tree, stone, or ground it rests against. This matters especially during the day, when many owls are inactive and vulnerable to being seen. A roosting owl often depends on remaining undisturbed while brighter light fills the landscape. If the bird were obvious, other animals might mob it, predators might spot it, or human attention might drive it away from a useful resting place. Camouflage helps prevent all of that. It gives the owl a way to remain in the world without constantly having to flee from it. In some species, ear tufts may contribute to this effect. These tufts are not ears, as many people first imagine, but feathers rising from the head. Their exact functions can vary, and not all owls have them. But one likely use is visual disruption. An owl with ear tufts pressed upright may resemble a broken branch or rough projection, rather than a smooth-headed bird. This can make the perched body even harder to recognize at a glance. Posture helps too. An owl does not simply rely on color. It often changes the way it holds itself. When at ease, the body may look rounded and soft. But when trying to avoid notice, some owls stretch upward, narrow the body, flatten the feathers, and hold the head in a way that makes the whole form resemble part of the tree or another quiet vertical shape in the environment. The body becomes less obviously bird-like. It becomes a line among lines. This is important because camouflage is not only about predator avoidance in the dramatic sense. It is about reducing all kinds of unwanted attention. A well-hidden owl can sleep more safely. It can conserve energy. It can remain close to useful hunting grounds without needing to move to distant shelter each morning. In that sense, invisibility is part of daily survival, not just emergency survival. Different habitats shape different kinds of concealment. A snowy owl resting on pale ground or among snow patches does not need the same feather pattern as a forest owl pressed against bark. A burrowing owl near earth tones and short grass blends differently from a screech owl tucked into a tree cavity opening. Yet the principle remains the same. The owl's feathers are not simply decorative. They are working surfaces, tuned to the visual problems of the place where the bird lives. That is part of why an owl can feel so suddenly present when it is finally noticed. The bird may not have arrived at that moment. It may have been there all along, held in plain sight by the simple fact that its body was too well matched to the world around it. This changes how we should think about owl invisibility. It is not an accident of being brown or grey. It is a strategy. A roosting owl survives not only by leaving the scene, but by remaining within it so quietly and so convincingly that the scene seems complete without revealing the bird inside it. And that concealment connects naturally to another truth. To understand owls fully, it helps to ask not just how they look, but how they live across a full day and night. To many people, the owl seems like a creature of darkness alone. That idea is understandable. Owls are so often heard at night, glimpsed at dusk, or imagined against moonlight, that it can feel natural to think of them as birds entirely cut off from the day. But the real rhythm of an owl's life is more flexible than that. The owl is not only a symbol of darkness, it is an animal shaped by timing, energy, prey movement, and the changing conditions of the world around it. Many owls are nocturnal, which means they are most active at night. This fits well with everything we have already seen. Large, light-gathering eyes, sensitive hearing, quiet flight, and camouflage all support life in dim conditions. Night can also offer practical advantages. Many small mammals are active after sunset, and darkness may reduce competition with day-hunting birds such as hawks. For an owl, the night can be a useful working time, but not all owls follow the same schedule in exactly the same way. Some are crepuscular, meaning they are especially active around dawn and dusk. These are the softer edges of the day when light is low, shadows are long, and many prey animals begin to stir. In those hours, the owl gains some of the advantages of dim conditions without needing to wait for full darkness. For certain species, this can be the most efficient balance. A few owls are more willing to hunt in daylight under the right conditions. Burrowing owls, for example, are often active during the day, especially in open country, where their prey and habitat differ from those of deep forest night hunters. Snowy owls also live in a world where the usual rules of day and night can blur, especially in the far north where summer daylight stretches for long hours. In such places, strict darkness cannot be the only guide. The owl must instead respond to opportunity. That is really the deeper truth. Owl life is governed less by mystery than by energy. The bird must eat often enough to survive. It must hunt when prey is available and when conditions favor success. If prey moves mostly at night, then night becomes the right time. If prey is more exposed at dawn, dusk, or even during the day, then activity may shift accordingly. The owl's schedule is not a rigid symbol. It is a practical answer. When not active, many owls spend long hours roosting. Roosting is more than simple rest. It is a way of conserving energy and reducing detection. A quiet roost site allows the bird to remain safe during inactive hours, especially if those hours fall in daylight, when the owl may be easier for other animals to notice. A well-chosen roost helps the owl stay sheltered from weather, hidden from harassment, and close enough to future hunting ground. Roosting posture matters too. An owl at rest often becomes part of the landscape in a different way from when it is alert and hunting. The feathers settle. The body narrows or softens depending on the species and setting. The eyelids may close partly or fully. The intense, forward-looking hunter becomes a still shape in bark, shadow, or beam light, waiting for the world to turn again toward the hours that suit it best. Season can change this rhythm. During breeding, an owl may need to hunt more often, feed a mate, or bring food repeatedly to chicks. In winter, hunger may push some species into more daytime activity than usual. During harsh weather, wind or heavy rain may shift the best times for movement. So even within one species, the daily pattern can bend. This helps explain why the phrase night owl fits people so easily, but also why it can oversimplify the bird itself. We use the owl to describe late wakefulness because the owl feels like the bird of after-hours life, the one that remains alert while much of the world is resting. But real owls do not stay awake late as a personality trait. They move when survival makes movement worthwhile. That does not make them less bound to night in the human imagination. If anything, it makes the relationship more interesting. The owl is linked with darkness, not because darkness is all it knows, but because it has become exceptionally good at using the quieter, dimmer, less crowded parts of the day. But daily rhythm is only part of the story, because as seasons turn, the owl faces a much larger test. Night changes, prey changes, and in many places, winter changes everything. When winter arrives, the owl's quiet skill meets a harder world. The same bird that moved so precisely through autumn darkness now faces new limits. Cold air changes the cost of being alive. Prey can become less visible, less active, or less available. Snow can cover the ground. Wind can interfere with sound. Long nights may offer more hunting time in some places, but they also demand more energy. Winter does not erase the owl's strengths. It tests them. For many owls, food becomes the central problem. A small mammal hidden under snow is still there, but it may be harder to reach. Snow cover can muffle movement, but it can also reveal it in another way. An animal tunneling just beneath the surface may create faint sounds that a listening owl can still detect. In this sense, snow is not simply an obstacle. It changes the balance of information. The owl must adapt to a world where hearing may become even more important, while the final strike may require greater force or a more exact angle. Prey populations also rise and fall over time, and winter can make those cycles matter more sharply. In years when rodents are abundant, many owls may pass through winter with relative success. In poorer years, the pressure increases quickly. A landscape that seemed full of food in one season may feel much emptier in the next. Because many owl species depend heavily on small mammals, especially voles and mice, their fortunes are often closely tied to the fortunes of those animals. That dependence can change behavior. Some owls that are usually more active at night may begin hunting more often in daylight during winter, simply because the need for food becomes greater. If a bird must spend more hours searching to meet its energy needs, it may no longer be able to limit activity to the safest or most familiar times. Hunger can widen the rhythm of the day. Cold itself also changes the equation. A winter owl must hold on to body heat while still remaining light enough to fly well. Feathers become especially important here. The plumage that helps shape silent flight and camouflage also traps warm air close to the body. A roost site sheltered from wind can reduce energy loss. Quiet stillness, which seems so natural in an owl, also conserves strength. Every movement has a cost in winter. An unnecessary movement becomes harder to afford. Some owl species respond to winter by moving. Snowy owls offer one of the clearest examples. In some years, when prey such as lemmings declines in the far north, snowy owls may travel much farther south than usual. These movements, sometimes called eruptions, are not random wanderings. They reflect real pressure in the landscape. A region that no longer supports enough prey pushes the bird outward into new territory. That outward movement can create the impression that the owl has appeared suddenly and mysteriously in places where it is not usually expected. But behind that appearance is a practical reason. Winter has shifted the balance of survival, and the owl has responded the only way it can. Move, search, listen, and try again somewhere else. Not every species moves so dramatically, of course. Many remain within familiar territories year-round, adjusting through behavior rather than travel. They may choose more sheltered roosts, hunt more often in certain weather, or depend on memory of the landscape to return to places where prey is most likely to remain active. A known field edge, a sheltered meadow, a stand of trees beside open ground, all may become more important in a lean season. Winter also changes the sound of the world. Leaves are gone from many trees. Snow absorbs some noises and sharpens others. Frozen ground reflects footsteps differently. Open air may carry calls farther. The owl, already so dependent on subtle information, must read this altered world with care. So winter reveals something important about owls. Their grace is real, but it is not effortless. The quiet, controlled hunter is always living within limits set by weather, prey, energy, and time. In easier seasons, those limits may be less visible. In winter, they come forward. And that leads naturally into a wider ecological truth, because an owl is never only itself. It is part of a food web, shaping other lives even as other forces shape its own. The owl is easy to picture alone. A single bird on a post, a shape in a tree, a face turned toward darkness. So much of the owl's presence feels solitary that it is easy to forget something larger. The owl is not only a watcher in the night. It is part of a much wider system of lives connected through hunger, movement, shelter, and change. It belongs to a food web, and that means it is never acting alone, even when it seems to be. One of the clearest ways owls shape that web is through predation. Many owls feed heavily on rodents, especially mice and voles. Others take insects, small birds, frogs, reptiles, or mammals depending on their size and habitat. By doing this, owls help regulate populations of the animals they hunt. A field with hunting owls is not the same as a field without them. A forest edge where small mammals are regularly taken is being shaped, little by little, by the presence of those hunters. These effects can spread outward in quiet ways. If rodents are kept in lower numbers, crops may suffer less damage. Seeds may have a better chance of remaining in the ground long enough to sprout. Stored grain may be safer in farm settings. In some situations, lower rodent abundance may also affect disease risk, since certain small mammals can help spread ticks, fleas, or pathogens through a landscape. The owl does not plan any of this, of course. It is simply feeding itself. But in feeding itself, it changes the conditions around it. Insect-eating owls do something similar on a smaller scale. They reduce the abundance of the insects they catch, which can affect plant damage, insect competition, and the flow of energy upward through the ecosystem. A single owl does not control a whole landscape, but many predators together create pressure that shapes how prey populations rise, fall, and move. And yet the owl is not outside the food web looking in. It is inside it. Owls face competition from other predators that want the same prey. Hawks may hunt some of the same rodents or birds during the day that owls pursue at night. Foxes may hunt the same fields. Snakes, wildcats, weasels, or larger owls may compete in certain habitats as well. Even when two predators do not hunt at exactly the same hour, they may still be drawing from the same pool of available life. Different owl species often reduce this competition by dividing resources. One species may focus on insects, another may take mostly rodents. One may prefer open fields, another may stay near forest edge. One may hunt early in the evening, while another is more active later at night or toward dawn. This kind of separation allows multiple species to exist in the same general region without each one doing exactly the same thing. Size matters here too. A very small owl cannot hunt what a very large owl can. That difference helps sort the food web into layers. Tiny prey may belong mostly to tiny hunters. Larger prey may fall within the range of stronger birds. In this way, the owl world contains its own internal order, with different species fitted to different portions of the living system around them. The owl also faces danger most strongly at its most vulnerable stages. Eggs and chicks may be taken by nest predators such as raccoons, snakes, martens, larger birds, or other animals depending on where the nest is placed. A cavity nest may offer more protection than an exposed ledge. A burrow may reduce one danger while increasing another. So even before a young owl becomes a hunter, it is already part of the web as something that can be hunted in turn. That is important because it keeps the owl from becoming too simple in our minds. It is not just a controller of other populations. It is also a participant in the same unstable system. It depends on prey abundance. It is shaped by competitors. It risks losing eggs and chicks. It succeeds or fails within a network of pressures that extend far beyond its own body. So the owl's role in ecosystems is both direct and indirect. Directly, it takes prey and changes prey numbers. Indirectly, those changes can ripple outward into plants, seeds, stored grain, predator competition, and local balance. The owl is part of the way energy moves through the landscape, from plant to herbivore to hunter and onward again. And because owls so often live near fields, barns, roads, and towns, the food web they enter is often partly human-made. That is where the relationship between owls and people becomes especially visible. For many people, the owl is not first encountered in deep wilderness. It is encountered closer than that. Near a road at dusk, on a fence post beside an open field, in the rafters of a barn, in a tall tree near the edge of a neighborhood, in the brief shape that crosses headlights and disappears again. The owl may feel wild, and it is wild, but it has long lived beside human spaces as well as beyond them. This is especially true for species that do well in open country. Barn owls are one of the clearest examples. Farmland can create broad hunting ground rich in rodents, and that can make certain human-shaped landscapes attractive to them. A field full of grasses, ditches, and small mammals can support an owl very well, especially if nearby roosting or nesting spaces are available. In that sense, farming can accidentally create useful habitat, at least for some species and under some conditions. Owls also make use of structures people leave behind. Barns, silos, church towers, old buildings, broken walls, and nest boxes can all become resting or nesting places. Tree cavities in parks, shelter belts, and older streets can matter too. Some owls live close enough to people that their calls become part of ordinary local life. A person may never go looking for an owl, yet still grow up hearing one from a backyard tree or seeing one lift from a roadside ditch in winter. This close coexistence helps explain why owls appear so often in human stories, language, and memory. They are not only distant creatures of the imagination. In many places, they have been regular neighbors, seen or heard just often enough to remain familiar, but still hidden enough to feel strange. Yet human landscapes do not help all owls equally. A species that uses open farmland may benefit from certain kinds of land clearing, while a forest owl may decline if old woodland is cut back too far. A cavity nesting owl may lose opportunities if dead trees are removed. A species that needs large, quiet territories may struggle when roads, buildings, and fragments of habitat divide the land into smaller pieces. So the presence of people can create both opportunities and losses at the same time. Artificial light is one example of this mixed influence. In some situations, light may attract insects and create feeding opportunities for certain small owls. But for many species, too much light changes the nighttime environment in ways that may interfere with movement, hunting, or concealment. A brightened landscape is not the same as a dark one, even when food is present. Roads create another kind of problem. Some owls hunt low over open ground, and roadsides can attract rodents. That may draw the owl in, but it also places a low-flying bird into the path of fast-moving vehicles. A straight strip of road through open habitat can become both useful hunting space and a serious source of danger. Poison is another quiet risk. Rodenticides used to kill rats and mice may move upward through the food web when an owl eats poison prey. The owl does not need to touch the bait itself. It only needs to catch the animal that did. In this way, a landscape that seems suitable on the surface can hide an unseen threat. Windows, wires, shrinking habitat, and the loss of nesting structures can add to the pressure. So human places are not simply good or bad for owls. They are mixed. They offer shelter in one form and danger in another. They create prey in some settings and remove cover in others. The owl that lives near us is often living inside that tension. And still, many owls remain close enough to human life to be noticed again and again. That repeated contact has shaped how people think about them. A bird heard regularly from the edge of a field or seen perched above a lane does not stay only biological in the human mind. It begins to gather meaning. Because once a bird is seen or heard regularly at the edge of human life, the human mind begins to do what it always does. It begins to assign meaning. That meaning did not appear from nowhere. People across the world have attached powerful ideas to owls for a very long time. In some places, owls have been linked with wisdom. In others, with death, secrecy, warning, luck, protection, or hidden knowledge. The same bird can be treated as sacred in one culture and unsettling in another. That might seem contradictory at first, but the contradiction begins to make sense once you remember what kind of animal the owl is and how people usually encounter it. Most people do not meet owls in bright, easy conditions. They hear them at night. They glimpse them briefly. They notice the face before they understand the body. They hear a call from darkness and do not immediately know how far away it is, what made it, or what the bird is doing. Even when the owl is seen clearly, it often appears strangely deliberate. The forward-facing eyes, the still posture, the wide head turn, and the sudden silent movement all give the impression of intention. The owl can seem less like a bird passing through and more like a presence already there, watching. That impression matters. Human beings are not equally comfortable in all environments, and darkness has always carried uncertainty. At night, sight becomes less reliable. Sounds seem larger. Distance becomes harder to judge. The unseen feels more active because more of the world escapes immediate explanation. Animals that move easily through darkness often gather symbolic weight for that reason alone. They seem adapted to a world humans do not fully share. Owls fit that pattern almost perfectly. They are genuinely specialized for nighttime perception and movement. Their eyes gather low light. Their hearing can locate faint prey sounds. Their feathers allow quiet flight. Their calls travel through darkness in ways that make their presence felt even when the bird itself remains hidden. So when people began treating owls as unusual or meaningful, they were responding to something real. The biology came first. The symbolism grew around it. That is why owls could become so many different things in the human imagination. A bird that seems calm and watchful may become a symbol of wisdom. A bird heard near houses, graveyards, ruins, or lonely roads at night may become associated with death or warning. A bird that appears suddenly and disappears without sound may feel linked to secrecy, spirit, or the unseen. None of these meanings are built into the owl itself, of course, but all of them grow from the same set of repeated human experiences. Even the owl's face may have played a role. Many birds look sideways into the world, but the owl faces it more directly. That directness can feel almost human to people, even though the bird is behaving like a bird, not like a person. Human minds are very quick to notice faces and to assign emotion or intention to them. The owl's face invites that kind of attention, especially when combined with stillness. And then there is the voice. A call heard in darkness is not just information. It is atmosphere. It changes how a place feels. A single owl call can make a field seem more remote, a forest more inhabited, a night more alive. If a sound like that becomes part of regular life, people begin to weave it into belief, story, warning, and memory. So scientific understanding does not erase owl symbolism. It explains why it formed so strongly. Once you know what an owl is built to do, the old meanings become easier to understand. A night-specialized bird with a striking face, unusual voice, and nearly silent movement was always likely to attract interpretation. Humans are meaning-making creatures. The owl gives them rich material. That is also why the owl remains powerful even now. Modern knowledge has not emptied the bird of significance. It has simply shifted the source of wonder. What earlier people may have felt as omen or mystery, we can now also see as adaptation, anatomy, and ecology. The feeling remains, but it stands on clearer ground. And once symbolism fades back into biology, what remains is a quieter truth. Owls are not only powerful symbols, they are vulnerable, real animals living inside changing environments. For all their precision, owls are not protected from everything. They are beautifully fitted to low light, soft sound, and patient hunting. But those strengths evolved within natural landscapes. When the landscape changes quickly, the owl cannot always change with it. So the modern story of owls is not only about mystery, silence, and skill. It is also about pressure. Habitat can disappear. Nest sites can vanish. Food webs can be altered. Dangers can enter the landscape in forms the owl's body was never shaped to understand. One of the clearest threats is habitat loss. An owl may need more than one thing from a place. It may need open ground for hunting, trees for roosting, cavities for nesting, and enough distance from disturbance to rest safely. When forests are cleared, old trees removed, wetlands drained, or grasslands converted, those needs may no longer fit together. A place can remain visually green or open and still stop functioning as owl habitat if the right structures are gone. This matters especially for species with narrow requirements. A generalist owl may adjust more easily to change, but a specialist may not. An owl that needs mature forest, large cavities, or a particular prey base can decline quickly when those conditions are broken apart. So conservation is rarely about saving owls in a broad and simple sense. It is about preserving the exact kinds of places different owls depend on. Rodenticides are another serious problem, and they work in a hidden way. An owl does not need to eat poison directly. If it catches a poison rodent, the chemicals can move upward into the owl's body. This is part of the danger of food webs. What enters one level may not stay there. A rodent weakened by poison may even become easier to catch, which makes the risk greater, not smaller. The owl succeeds at hunting and is harmed by the success. Roads create a different kind of threat. Many owls fly low when hunting, especially over open country. Roadsides may attract small mammals, which makes them useful hunting zones. But the same low flight that works well over fields becomes dangerous near vehicles. A bird crossing the road at the wrong height or at the wrong moment may not have time to avoid impact. So a feature that seems minor from a human point of view can become deadly when repeated night after night. Collisions with wires, fences, or windows add to that risk in certain places. Artificial light can also alter behavior, prey movement, and the quality of darkness itself. For an animal built around subtle sensory conditions, a brightly changed night is not the same world. Logging and development can affect owls differently depending on the species. Some may tolerate a degree of change. Others may lose nesting cavities when dead trees are removed, lose roost cover when woods are thinned, or lose hunting ground when patches of habitat become too small and fragmented. Large-scale land conversion can separate the parts of the landscape an owl once used together, leaving the bird with shelter in one place and food in another, but no safe link between them. And yet there is room for care as well as concern. Nest boxes have helped some species, especially where natural cavities or old structures have declined. Protecting grassland, forest edge, mature woodland, or open hunting territory can support breeding and survival. In some places, changing farming practices or reducing poison use has made a real difference. Small actions can matter when they are shaped around the actual needs of a species, rather than around a vague fondness for owls in general. That point is important. Conservation works best when it respects difference. A barn owl does not need exactly what a boreal owl needs. A burrowing owl does not live the same life as a forest screech owl. To protect owls well, people have to see them clearly, not as one symbolic creature, but as many real species with many real ecological needs. That brings the story back to what has always made owls so remarkable. Their lives are not abstract. Every feather edge, every hunting pattern, every roosting choice, every nest site belongs to a relationship between body and world. When the world changes too sharply, that relationship is strained. And after all of that, the final feeling the owl leaves behind is not only one of mystery or fragility, but one of extraordinary fit, as though night itself shaped a bird to move within it. Now, the owl has become many things at once. It is a bird of low light and fine sound, a hunter of fields, forests, barns, and open ground, a keeper of stillness, a listener in darkness, a creature that has lived beside human beings for so long that we gave part of our own language to it, calling some people night owls, as though the owl had become our clearest symbol for wakefulness after dark. And yet, for all the meanings people have placed around it, the owl remains most remarkable in its reality. Its form has been shaped with unusual care by the demands of its world. The large eyes, built to gather weak light, the facial disc, turning the face itself into part of the listening system, the ears, so precise that sound becomes a map, the feathers, soft enough to quiet the body in motion, the neck, turning where the eyes cannot, the talons, closing with exact timing, the plumage, breaking up the outline until the bird seems to vanish into bark, grass, snow, or shadow. None of this is accidental. Each part belongs to the same larger answer. That answer is adaptation. Owls remind us that an animal does not need to be fast in every way to thrive. It does not need to dominate every environment. It only needs to become deeply suited to the one it lives in. The owl is not a general expression of bird life. It is a narrow, elegant solution to a particular set of problems. How do you hunt when light is low? How do you move without warning what you pursue? How do you keep listening while you fly? How do you remain hidden when the day returns? How do you survive in a world where small sounds matter and stillness itself can be a skill? The owl answers all of those questions with its body. That may be why the human response to owls has always felt so strong. Long before science had precise words for feather fringes, rod cells, asymmetrical ears, or auditory processing, people were still noticing the same things. They noticed that the owl seemed able to see what they could not. They noticed that it appeared where darkness was thickest. They noticed the sudden turn of the face, the strange stillness, the voice carried through the night, the flight that seemed almost too quiet to belong to an ordinary bird. In that sense, human fascination with owls has always been partly scientific, even when it was expressed through story, symbol, or superstition. People were responding to real features. They did not always explain them in anatomical language, but they were noticing them all the same. And what they noticed was that the night was not empty. That may be one of the owl's quietest lessons. To us, darkness can feel like an absence, a fading of information, a time when the world grows less detailed and less knowable. But the owl reveals another version of night, a night full of texture, sound, movement, and life. A world where grass still stirs, branches still carry weight, snow still hides motion, and air still holds the paths of wings. The owl lives in that world not as a visitor, but as a natural part of it. So the owl becomes symbolic not because it escapes explanation, but because explanation deepens the wonder. The more clearly we understand the bird, the more complete it feels. Not less mysterious, but more meaningfully so. Its mystery is no longer emptiness. It is structure. It is function. It is the beauty of a life shaped with astonishing precision by the conditions around it. And perhaps that is the most calming thing about the owl in the end. Not that it is strange, though it is. Not that it is beautiful, though it is. But that it belongs so completely to its place in the world. It reminds us that nature is full of forms that seem almost dreamlike until we look closely and see that they were shaped patiently, piece by piece, by the quiet logic of survival. So now the owl can return to distance, to a branch half hidden against the dark, to a field cooling under the night sky, to a barn beam, a hollow tree, a fence post, a line of silent air. And as it fades back into shadow, what remains is not only the image of the bird, but the feeling that the night itself was always fuller than it first appeared. More awake, more listening, more alive. And somewhere beyond sight, the owl remains within it, turning its pale face through the dark, exactly where it belongs.